like that, and we will join, and we will share, and this should pop up over here. All right, so today, I don't want that. I do want that. Okay, so today we'll be doing lesson 6. Of course, you're going to the calendar spreadsheet first. Oh, hold on a second. Okay, so you good? Good. Today we're gonna do lesson 6. If you were not here last time, not a great time to miss. We started programming. Okay, the replay from last time is up. You can use that if you, well, if you didn't finish, there we go. This is like the literal replay from class that you can use to follow along. Please be listening to it when you are watching it. There we go. You're not going to get much out of it by just going through it and trying to learn by seeing what I'm doing and copying it. But that's better than nothing. Okay. Again, those people who were here last time heard this, but this is really for the people that were not here. You need to show up caught up. Okay. And not just for the sake of it's a good best practices, academically. We learn at things every day that we need in order to learn the next thing the next day. Okay. Plus, if you're going to do it, you might as well do it on time. Just in general. That's true for everything here, especially. Okay, so this, that, the other. Let's take a look at our lesson 6 situation. Okay, new concepts, no video today. New concepts, well, abstraction is not new. We've been doing that forever. Okay, we learned about functions last time. New concept is top-down design. Okay, last time when we did our design, we did the draw diamond thing. And the solution for draw diamond was, or the process was first draw a step. Okay, the first step was making a function that could draw one step. Then the next function was making, or the next challenge was making a function that would use 3 of those draw steps plus a little bit to do a draw side. And then we used, for the last one, draw diamond was all of them. That is what we call ground up or bottom up design, where you're solving the smallest problem and working your way up. That is a completely valid way of doing things. And I would say probably the way that most people do them, including myself, it seems a logical way to do it. Now, there is another way to do things called top down. Top down is solving the big problem first. So for what we do last time, the draw diamond situation would have been like write a function. The first function you write would be draw diamond. Okay, so like before you even begin, you would be doing draw diamond and draw diamond. Well, typos. Well, caps locks. There we go. And then draw diamond would call draw side 3 times because you're looking at it and you're planning ahead that draw diamond, I'm already planning draw diamond is going to be broken up into draw side. And then I know that draw side is going to be broken up into draw step. Okay, so this is one way, this is the top down equivalent. And the problem with this is you can't really test it as you go. Okay, the way we did draw diamond for real was draw one step, make sure it works, and then draw side, make sure it works. Top down, you kind of just have to go for it. And you kind of have to have a complete plan before you can even start. And that's why I don't recommend it, even though it is the name of this lesson 6. Okay, The worksheet that's associated, we aren't going to do. It's essentially the exact same thing as the main challenge, but you solve it on paper first. Okay. So that's not super worth our time. Whichever way you do this, either the bottom up or top down way of solving things is fine. All right. We are interested in the outcome and making sure that it works more than anything. Okay, so here we'll go straight to bubble 2 of the current lesson. And our goal is to create this entire shape using multiple functions. This is the point that people that aren't really into paying attention will do something like 125 lines of code that's just turn forward, turn, da, 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 all for days to get it done. That is wrong. Okay. That is the wrong, not just the wrong way of doing it for your future understanding of things. That is incorrect for this lesson. Okay. So you need to understand the power of functions. We'll be using them for everything forever. Okay. So for this challenge, you are doing the same thing as Draw Diamond, where you're breaking this up into smaller challenges, solving them, and figuring out how to put them together. Okay, so step 1 is planning. How are you going to break this down? Okay, I see this a couple ways. One way is I see this 4 separate crosses that stick out from the origin. Okay, that's one way to break it down, in which case you would need to solve one of these draw crosses, which draw cross would be made up of a couple of these sort of spikes that stick out. Okay, another way to solve it would be something like 5 of these plus signs, in which case you would need to, okay, if you see 5 plus signs there, you would need to write a function that solves one of those plus signs and then figure out how to get them to their origin point so they can draw the particular plus sign that you want it to be. Okay, so you're going to choose one of those 2. You're going to work on it either on your own or collaboratively. But remember, even if you're working with people, you need to do your own work. There's no co-working, co-submitting for this. And that's all the direction you're going to get at this point. Okay, so go ahead and jump in. And obviously at some point we will please do remember to keep your code neat. Okay, I'm not going to take off if you don't have white space between functions and between whatever. But do yourself a favor, put some line breaks in there so you can actually read it. I know you'll agree that that's a lot easier to read than just, pages of this. Also, another thing, do listen to this. You would never have a function definition inside of a definition. Okay? And the people not listening now have the potential of that happening. Okay? You would never have a definition inside of a definition. There are obscure cases that it would maybe help, but they won't happen in this room. Okay, so go ahead and get going. 1, 2, 3, go. Okay, so I'm looking at some people doing their stuff, and the key to this is that you have layers, meaning you have functions that call other functions. Just having, a function that does a bunch of these things, and then having another function that um, does a bunch of other things, and you're just calling, one thing after another where essentially it's just calling all the blue things straight through. That's not the point. Okay. You would have portions of it that are used to solve the next one. Okay. Keep going. let's at least talk about this first one and maybe give you some insight on how to do the next one in a way that won't require you to redo it. Okay, so again, everything here is the plan. Okay, so planning this out is key. Okay, clearly the way I'm going to solve it is if there are 4 of these crosses. Okay, and I know I said before that we don't really need top down, but it doesn't really hurt at this point. Just as a framework at this point. But no, let's just solve one of the draw crosses. Okay, so maybe here's another thing. Use meaningful and descriptive names. And of course, if you are drawing a cross, draw cross is a great name for it. But if you recall from the last one, everything started with draw. What good is it if everything starts with draw? Okay, if you have everything started with draw, that's fine. Doesn't matter. I'm just saying make things easy for you or plan on making things easier, plan to make things easier. I can just call it cross. Okay. And so there's the call to it that does nothing by itself. I need a function definition. Okay. And so draw cross is going to be made up of some stuff. The way, having done this a bunch, the way I think is pretty effective is thinking about, okay, what is this made up of? This is made up of 3 of these little things. Okay. And you could call it one of these and one of these. That's fine also. But the way I see these, this like branch is an out, a to left, and then return. But just like what we learned last time from Draw Diamond is your function works out best if you prepare it for the next one, the way that we had draw step 3 times and then that extra little tail to make it so that we could just draw side 4 times. Okay, if I do out and back, out, double turn, and back, which out and back isn't a bad function. It will sort of make sense. I'll probably call it like branch or something. If I do an out and back and a half turn or a 90-degree turn so it's pointing up, I can do that same thing, an out and back with a 90-degree turn. I'll be pointing east. I'll do an out and back and then return and I'll a 90-degree left and I'll be pointing south, which is fine. Okay, so even though I'm starting this point, I'm going to solve the problem as if I'm here. Okay. Well, actually, let's solve the problem of getting there. Okay. So in order to get here, in order to do these 3 things, I am going to start pointing west. So I need to get here. I need 2 forward and a left turn before I even do a branch situation. So draw cross is going to start for me. And as always, there are a bunch of ways to do this. Okay. And again, I know I said we weren't going to do top down, but this is kind of top down. It's sort of middle out for those of you with pop culture references. Okay. So I've got it up to this point, and now that's me right there pointing west. Now I know I'm going to do out and back and a turn, out and back and a turn, out and back and a turn. I need a function that does out and back and a turn. So let's write a new function. Let's call it branch. Resetting's a good idea. I wish it had more pixels. There we go. I guess I could zoom out. Let's name this function branch. And just walking it through in my head from here, it is going to be a forward, 1 unit of forward, a double left, another unit of forward, and then a bonus left to be prepared for the next one. So it's a forward, a double left, another forward, and a left. And if I do it correctly, it will look like that. Okay, but of course I need to call branch. You'll start to see yellow triangles and red squares in your code. A yellow triangle is like a caution and a red triangle is a warning. A red square is a warning. A red square will prevent your program from running. A yellow triangle means something is not as you planned, probably. And this one says we have a function definition for this function, but we're not using it, and that's your hint. Okay, so cross is going to have a draw or a branch on it. Let's see what happens with 1. Okay, so it gets me to there. How about let's call it twice more. There we go, not too bad. Now, again, our goal for cross is so that it finishes ready for the next one. Now, you could do forward, forward, and then now you're facing south, and you draw the cross that goes that way, and you go back to the middle, and then you draw the cross this way. But just like I showed with the, keep turning left, one left turn to do the next one, I'm going to set this up to do the one that is east, I guess. And that's actually fortunate because think of what you need to do in order to do that. It's a forward, and a left, which we already did a forward, and a left to get it to here. If you see a chunk of code that is repeated a bunch, that is a great opportunity for another function. Okay, so this does solve it. Okay, it solves one cross ready for the next cross, which we can just do this, call it 4 times, and have it done. Now, we can improve this, refactoring, if you want to call it that, because we have, and this is only a minor improvement, but it certainly looks better. This sort of double forward left that is needed to do sort of a reset, because it's repeated, let's have it its own function. How about reset turtle? Something like that. Reset center. How about center reset? You'll find that there are a lot of reserved words in any sort of programming, like syntax. You can't name a function. You can't name it. I mean, there's just a handful of words you can't use. Reset tends to be one of them, depending on the context. Run tends to be one of them. Okay, regardless, this center reset is just this. Okay, so anywhere that, that's not what I meant to do. Let's copy this. Anywhere that I have this, I can replace it. What the heck is going on? Where's my cursor? Oh, that's why, because it doesn't work that way. Okay, because I have this function called center reset, I can replace these 3 lines of code with a call to center reset. And it's the same. Okay, and then I can also replace these 3 lines of code with a call to center reset, because that's how functions work. Okay, and there you go. Draw snowflake. But a slight improvement still, these 3 function calls should probably be in their own function called a snowflake. Okay, and then we of course would need to call the function named snowflake. And there you go, 1 snowflake. So let's look at the next one. Again, however you solve this, so long as you're using functions that call other functions, you're on the right track. Okay, and of course hitting finish to make sure that your work, guarantee it saves. It frequently will regardless, so you're not guaranteed to lose it. In fact, it's super rare. It just doesn't guarantee it unless you hit save or hit finish. Okay, so we've seen this one before, and it was very tedious to, drag out at least 44 lines of code. Most of you are probably in the 80s. That's fine, because just this brute force type of programming is not common or useful. Okay, but using functions and lower and high level functions is useful. And that's what we are doing here. Okay, layers of function. How are you going to break this up? Okay, clearly there are some rows, and those rows are made up of boxes or squares. Okay, so go ahead and give it a shot. We're looking for functions that call other functions. Okay, same basic idea as a second ago. Also, white space is our friend. Line breaks, you'd probably call them. Okay, and go. All right, let's go over this, at least the main bits, and I'll show you one way to do it. And of course, if your way also works, as long as it's doing the abstraction, the layered functions, you'll be fine. Okay, so this one, so it's clearly made up of rows, and each of the rows are clearly made up of boxes. So I definitely need at least one function that's boxes, or a box, as the case may be. And a box is going to be on there's going to be 3 boxes per row, and the row or the grid is going to be 3 rows. Not too bad. Now, planning this out, if you recall from last time, this is essentially a box that's to the front and right of where we're starting, with returning to the original spot as part of the issue. But if you recall from our box that's front to the right, we definitely would benefit from a right turn function, that triple left. But if we do every box clockwise and every grid clockwise, we're calling that function a bunch. And even though it is one function call in the function box, the right turn one, it's still 3 lefts being run. So it's probably a little more efficient to do that trick at the beginning, and then so that you can go around things counterclockwise, where each corner is just a series of left turns. Okay, so that's the way I'm going to show it, is a triple left just at the very beginning to set up, and then I'll be able to draw 1 box, and then 3 boxes will make a row, and then we'll figure out what we need in order to get to the point where we can just draw row, 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 your boat. And okay, so for first thing, folks, those of you half listening, now is a great time to start listening. The white space blocks are not a block in programming or in AppLab. When you start a new thing, generally a good idea to go put a few lines in and then double slash. Okay, double slash is a comment, and how they're actually used is different, but you'll notice if you don't have some block in there, when you're starting or after you have stuff, if you just put a bunch of lines in there, you don't get the blocks. You need some sort of something at the end, and slash is fine. Okay, so now we have a bunch of white space to work with, and that's fine. So we need, like I said, I'm just going to throw a triple left up there, just so at the beginning we're facing east, and then we could do counterclockwise. All right, so I definitely need a function that draws a box. Let's just call it box. And box is going to be forward, left, forward, left, forward, left, forward, left, just like you would draw a rectangle: forward, left, forward, left, forward, left, forward, left, which, I don't know, maybe you'd put forward, left in there in a function, but it's only 2 lines. So it's a lot like the way we did compression, where you need a certain amount of savings for it to be worth it. But yeah, so we hit box, and that gets us there. Now, if we had a row would just be 3 boxes, right? But that's not the case, because we need an extra step in order for it to actually draw 3. So at the end of my box function, I'm going to throw 1 more move forward there, and now 3 boxes will draw a row. Excellent. So let's put these 3 boxes in a function, and let's name this one row. Okay, and now nothing happens because I didn't call it. Okay, let me put some more of this stuff up at the top. And we'll put another one. I'll put one of these here. Okay, so we need to call row. Excuse me. Yeah, we need to invoke row. We need row to happen. Okay, so we have 1 row. The whole grid is just 3 rows. So what's going to happen there? Well, it's just going to keep drawing rows off the screen. So we need some way to go from the end of 1 row to be ready for the next row. Okay, so the position to be ready for the next row would be here, facing east. So how do we get there facing east? Well, we need to make a left turn, a forward, a left turn, 3 forwards, and a double left. That's a lot of code. It's also going to be needed to be done for each of the rows. So let's make it a new function. We'll just put it down here. How about reset row? And reset row, like I said, just solving it in your head, is going to be a left turn to face north, a forward to go up 1, another left will face us west. Then I need 3 forwards to get to the other end. And then I need a double left. Okay, well, I'll just do row, and then, what did I call this? Reset row? We'll just do one of each, and we'll see where it gets us. Okay, gets us to there. I need 2 more left turns in order for it to reset. And that puts us there. Okay, so we have row and then reset row. But since row is always going to be followed by a reset row, instead of doing like this, okay, row, reset row, row, reset row, okay, which does work, okay, because it always goes row and then reset row, we can just put reset row inside of this, okay, right here. So it's box, 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 and reset row. Box, box, box. Okay, so row is now 1 complete row ready for the next row. So 3 of them will solve it. Okay, but again, not complete because it'll just put us right there. First of all, this entire thing is going to be its own function called grid. And grid is just going to be our 3 rows. And get another one of these like that. Okay, and of course, in order for grid to work, we need to call it. We need to invoke it. Okay, and in order to get back here, okay, we could do a triple left as a right turn, which at that point, we probably should have a function named right. Okay, in fact, let's go ahead and do this. Let's put, oh no, please don't. Please be there. Ain't no way. It's all gone. Let's see. Let's see here. There's no way that's the end of it. Did I just for real lose everything? No. Okay. So I can put these, since I'm going to use it, I'm using it here at the beginning. I'm also going to use it to face south because I need to get back to the origin. We'll just make it a function and we'll name it right. And let's put these 3 lines of code in there. Okay, and then we'll, of course, call right at the beginning, just like it was. And in order to get back home after inside of grid, because this is our main thing, let's call right. Nope, that's not what I meant to do. That is what I meant to do. So that'll get us at the end facing south. Okay, and then I need a triple forward and a double left. I already have something that is, oh wait, this is left forward. Okay, never mind. It's not that super useful. Okay, so we can just hard code it in here, forward, 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 and then we'll still be facing south, so we need a double left at the end. So that right turn function wasn't super useful. It did clean up the top of the code a little bit, but there you go. Okay, quick breakdown. We have our function named right at the beginning just to face east. And then we have our main grid, and our grid is made up of 3 rows. And then the rest of this is just getting us back to the origin. Each row is 3 boxes, and that reset to go back ready for the next row. And the box is just 4 sides plus a little bit so that it can draw multiple boxes on that row. Okay, and for replay's sake, I'll always scroll through the code so you can take a look at it later. Okay, again, please use the line breaks. All right, let's take a look at the checks for understanding, which do require some amount of explanation, especially the one for bubble 4, because bubble 4 is a practice response for this project that we do in the spring. Okay, so the one for bubble 4, okay, AP practice, performance task, response. The performance task or the create task or digital portfolio are all the same thing. And like the main thing is the written response made up of a bunch of smaller prompts that are, it's not unreasonable, just don't worry about it at this point. But one of the prompts is about describing your development process. Okay. Here we are, this is the writing prompt for what would be your main project. That would be, a couple weeks of in-class work, and you'd have lots of development time that you could reflect on for this writing. We've been working on this for like 30 minutes or 45 minutes. So you don't have a ton of direct experience with this development iterative process, the step-by-step. Okay, incremental meaning like small steps, and iterative meaning over and over again. So there's that. Okay, this is part of the rubric for the project. We don't really have the context to explain how it fits into big picture stuff. So don't worry about how the rubric works for this. Okay, yeah, the actual scoring guideline. Okay, you are responsible for addressing the 2 prompts. Okay, or this prompt, but these are the explanation of what you're supposed to be writing. Okay, but you're writing it with regards to the snowflake problem. Or the grid. Okay, and you do kind of have to sort of visualize this as a longer term project in order to address the idea of a longer development process, but I think you can do it. Okay, bubble 5. Imagine this was a new project, okay, a new design to solve. What would your functions be? You don't need to actually program them. You can just be like, okay, what's the whole thing? Draw, S, okay. How would you write S? S, draws curve, okay. Then maybe like, U-turn would be another one or something like that. You just need to name the functions, and as long as the functions are named something useful, it will be easy to tell how you're solving this. Okay, or like how about triple forward would be one. Okay, whatever. If we were counting this as 1 unit of length, this is probably 4 units of length or something like that. I don't know, however you want to solve that. Okay, multiple choice, bubble 6, which of the following statements about writing functions and top-down design is not true? Functions help manage complexity in a program. Okay, top-down design leads to programs which feature multiple layers of abstraction. 2 programmers solving the same problem using top-down design should arrive at identical programs. Top-down design relies upon identifying sub-problems for a larger problem, or top-down design assists in identifying the layers of functions that will be used to solve a programming problem. Just one of those is incorrect. And abstraction to manage complexity. Okay, managing complexity is sort of the key word that goes along with abstraction. Okay, that's sort of the point, is, it's a lot easier to write a function, draw box, and use draw box 3 times to draw row, and use row 3 times to draw, rather than just forward, left, forward, left, forward, left, forward, 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 left, forward, left, forward, left, forward. That is much more complicated, much less elegant, much harder to fix or maintain or that sort of thing. Okay, so that's managing complexity. Okay, in the create performance task, you'll be asked to identify an abstraction in your program and explain how it manages the complexity of your program. Functions are a form of abstraction. Pick a function you wrote in your solution to the 3x3 square problem and explain how it manages complexity of your program. Okay, so those checks for understanding, as well as, well, you'll see in the assignments it says all bubbles. That's what that means. It means the entire lesson, the activities, as well as the checks for understanding. Okay, we had 20 minutes left. You should get this done before you leave, without a doubt. If you have any questions, let me know. Okay.